Perfect. Okay. So, Hassam, are you here?
Yes, I am.
I'm thinking it's 11 o'clock now. I'm thinking it's about time. You ready?
Yes, yes.
Yeah.
Please go ahead.
Okay. Welcome everybody to the Eco Concrete webinar. Um, I'm here with Hassam, who's going to be leading the charge for us today. If you guys have any questions, feel free to add them to the chat on the right side. I see we got a few people who are pouring in now. If you guys have any questions, feel free to add them to at the end. I will make sure we get a segment going so that we can address any questions. You guys can just add them to the chat and I'll make sure that we get these communicated to them. With that, Sam, do you want to take us away? Or do you want to,
Sure.
let's see.
Let me share my screen.
Perfect.
All right. Hello, everyone. Thank you very much for joining this webinar. My name is Hessam Azari Jafari, and I'm working as Deputy Director of the MIT Concrete Sustainability Hub. Today, I'm here to give you an introduction to the Eco Concrete competition and some of the changes compared to the previous version of the competition that was held in 2021. To start this presentation, I would like to bring the importance of the concrete and cement to your attention, which is the most commonly used building materials for various reasons. As you can see on the screen, we're using more than 4 billion tons of cement per year, and obviously a much larger amount of concrete because cement is only one constituent of the concrete, so 30 billion tons of concrete, and it's all because of the versatility, durability, obviously constructability, and more importantly, concrete is a democratic materials available everywhere around the world. So the availability and the economics of the cement and concrete have enabled us to build a lot of durable infrastructure and buildings to satisfy the requirements for population growth and residents around the globe. So this huge amount of cement and concrete use should make us think that how can we evaluate the sustainability aspects of concrete and what are the measures that we can include in order to mitigate the environmental impacts of the concrete. In this sense, we developed the ACI Eco Concrete competition in 2017 to get the new generation of the civil engineers and students to get engaged in concrete environmental assessments. So the objective of the eco-concrete competition is how can we develop a concrete mixture that will improve the durability and environmental impacts of the conventional concrete mixtures. For this purpose, we focus on durability and we translate the durability metrics into service life estimation. And on the other side, for the environmental impacts, we conduct life cycle assessments in order to quantify the environmental impacts of the concrete mixtures, not only focusing on the climate change impact, but also other impact categories, for example, the energy consumption or acidification, eutrophication, etc., to have a more holistic view of the concrete environmental impacts. So I'm going to start with the service life estimation and how do we do that in Eco Concrete competition. Here, our assumption for the Eco Concrete competition is that the concrete elements that we are going to design is exposed to an aggressive environment like the marine environment, and there's going to be chloride attacks that will take us to an issue and risk of the rebar corrosion. So we are targeting to assess the long-term chloride penetration resistance of the mixtures. And to evaluate this, we use Life 365, which is a publicly available online tool that you can use to estimate the service life of the concrete mixture and understand where the corrosion will initiate. For the environmental impact assessment, as I mentioned earlier, we are focusing on life cycle assessments, which is a quantitative method that will help us assess the potential environmental impacts. This case, we are evaluating the environmental impacts of the concrete mixture, and we are focusing on how much emissions and resources we will need to happen in order to extract the raw materials and produce the concrete mixtures. What do we do for the eco-concrete competition? You need to design two concrete mixtures. One is called the base case scenario, where you use straight Portland cement, meaning there is no SCMs or alternative materials in the mixture. Here I use the abbreviation BCS, and on the other side, this is your task to develop an alternative case scenario, or ACS, where you replace the Portland cement partially with alternative materials and SCMs. And then you will compare the environmental impacts of these two mixtures, as well as the service life, to understand how much benefits will occur if we shift from the base case scenario to alternative case scenario in terms of the service life extension and environmental impacts reduction. But we have some boundaries and constraints when we are designing our concrete mixtures, these two concrete mixtures. For the BCS, or base case scenario, your concrete mixture should at least include and incorporate 75% aggregates. So make sure that your aggregate mass is 75% of the total mass of the concrete. Your water to binder ratio must be fixed at 0.40 or 40%. And as I mentioned earlier, your binder should be 100% Portland cement. On the other hand, for the alternative case scenario, you need to replace the Portland cement by supplementary cementitious materials. The supplementary cementitious materials that you can use are those that are already included in the Life 365 online tool, which includes slag, fly ash, and silica fume. The maximum amount of replacement by supplementary cementitious materials is 40%. You can use multiple types of SCM, so making ternary or quaternary binder systems, meaning you can include 3 types of materials or 4 types of materials as binder if you get a better results. So please use your judgment and creativity to use these different types of SCMs in order to get the most benefits in terms of the service life and environmental impacts. Some other important notes is that your binder volume should be similar or exactly the same as what you have in the base case scenario. Your water to binder ratio, similar to the base case scenario, must be fixed at 0.40, and the aggregate volume and type shall be similar to what you have used for the base case scenario. Here are some of the notes and important points to consider when you are designing your concrete mixtures. But let's talk a little bit about the service life prediction and how can we use Life 365 to estimate the service life in this aggressive chloride ingress environments. So for that, you need to define both your base case scenario and alternative case scenario in Life 365. As I mentioned earlier, it used to be a software, but now it's an online tool that you can have access for free. You can see the link on the bottom right corner of the screen. feel free to log in and then use it in order to quantify the service life of your concrete. So here, our assumption for the eco concrete competition is we are going to evaluate the service life of a slab. So you need to consider a slab for your analysis. And the thickness of the slab is 20 centimeters, and the rebar depth is 5 centimeters or 50 millimeters. So these are all the parameters that must be fixed, and we evaluate that across all the teams in order to make sure that the assumptions are consistent. You also need to include your team name and team members as a part of this first page, which is the project details page, as you can see on the screen. Then below, on part 3 or box 3, you can see that you need to define 2 concrete mixtures, similar to what we discussed earlier, the BCS one and the ACS one. And then once you created these 2 fields, in the last page about the concrete mix design, then you'd be able to define the details and constituents as well. The next step is to define the exposure condition. So under the exposure tab, you can see on the left of the screenshot, you should define a location in order to uniformly assess the chloride concentration and the chloride attack in your to your slab. So you can see that for the purpose of this competition, we consider the state of Florida and the city of Tampa, and the exposure condition is defined as marine spray zone. Again, we must have all consistent assumptions. So all the teams must consider Florida, Tampa, and marine spray zone in this tab in order to have equal exposure condition for the concrete design. After defining your exposure condition, you need to define your mix designs. So it's important that in the project detail tab that I mentioned earlier, you define 2 fields, BCS and ACS. And by clicking on, for example, BCS, you can see that there is a box open in the middle of the screenshot. And this is where you need to identify and include some of the parameters relevant to the mix design, the type of the rebar that you're using for this competition as well. So here you will define the water to cementitious materials ratio. For the base case scenario, obviously the values for fly ash, slag, and silica fume should be 0. But for your alternative case scenario, these are some of the percentages that I would like to invite you to work on and optimize it to get the most benefits in terms of the service life extension and environmental impacts. The rebar type should be black steel. So again, all the teams must select black steel for the rebar. And for the rebar percentage, in terms of the concrete percentage volume, should be set as 3%. In this competition, no inhibitors or barriers should be considered for your alternative case or the base case scenario. So both of them should be set as none, as you can see on the screen. And the last part, when you click on the go or where you can see the results, we would like you to record your ACS, the alternative case scenario service life, and your base case scenario service life. And this fraction that you can see on the screen, the SS index ACS divided by SS index BCS, is the score that you need to include in your report. And this is the value that you will use to rank the service life improvement among all the teams. In other words, this is one of the numbers that we and other judges use in order to determine among all other teams how it was performed very well. So this is all about the service life simulation and getting your results. Moving on to the environmental impacts. On the ACI student competition, under the EcoConcrete competition webpage, you have access to an Excel tool, which is a streamlined LCA that will help you quantify the environmental impacts of your base case scenario and alternative case scenario mixtures. This is a relatively simple tool, but you need to pay attention to some of the details and make sure that you have already cross-checked all the important points and get the green boxes for all the cells. So once you open the Excel file in your computer, I would highly recommend using a personal computer with a Windows operation system. Sometimes some of my colleagues have difficulties with using it with Mac or iOS. So it's safe to say that it's totally working effectively for Windows OPs. So first, you have to consider the inputs for concrete mix design. As you can see on the left, it includes the quantity of the materials, each constituents, for example, Portland cement, fine and coarse aggregate, water, and any potential admixtures that you will use here. And at the end, there is a summary tab, as you can see on the right part of the screen, that you can see if you got all green cells, meaning that if you satisfied are what was required in the rules. And below the table at the bottom, plus the bars that you can see in the figure on the right, will show you the environmental impacts results. So the value that I would like everyone to include in their report is the average improvement in 5 different impact categories, including global warming, carcinogenic, ozone depletion, ecotoxicity, and fossil fuel depletion, and to report it in your written report and also your video recording. But let's go step by step. So first step to do the analysis, the life cycle assessment, is to insert the quantity of the materials. And as you can see on the right screenshot, you need to provide the transportation distance and mode, either road, rail, or waterway, in terms of kilometers for each mix design, both base case scenario and alternative case scenario. For this version of the competition, we are going to fix the transportation distance for slag, fly ash, and silica film. So you must use the numbers in terms of the transportation distance that is shown in this table to insert and fill out the Eco Concrete Calculator Excel tool. For slag, you must use 20-kilometer road or truck, no railway transportation, and 250 kilometers waterway transportation. For fly ash, you need to consider 100 kilometers truck transportation, 200 kilometers railway transportation, and 0 kilometer for waterway. Similarly, for silica fume, you need to consider 50-kilometer truck transportation, 200-kilometer railway transportation. So this table is only for different types of SCMs that you use in your mixtures and you examine. For Portland cement and aggregates, the transportation distance must be estimated and included in the tool based on the closest plant or quarries, like aggregate quarries, to your university. So while you must use the transportation distances for different types of SCMs, you still need to figure out where the cement plant is located in your region, or where the aggregates come from in your region as well. And moving on to step 3, where you can check if all the parameters were inserted correctly. You can see that these are all green boxes, meaning that the binder quantity in the base case scenario and alternative case scenario is identical. So checked. The water to binder ratio for both base case scenario and alternative case scenario is equal. And then the maximum 40% SCM replacement is already satisfied as well. And moving on to the last part where you can see the results, you can see, for example, in this case, on average, 37.5% environmental impacts was improved as a result of using the alternative case scenario instead of the base case scenario. And this is, again, the number that you need to report in your written document and your video as well. So these are all about the evaluations that you need to do in terms of the service life estimation and environmental impacts calculation. And after finishing these and obtaining your optimized results, meaning the best combination of the environmental impacts and service life extension, you need to start drafting your report. And these are some of the notes that I have for the report. So first of all, we need the reports to be submitted in PDF format. Please check the due dates from the competition webpage on the ACI website. The report should not exceed 20 pages, considering all the front page, table of content, etc. Please include the illustration of the maps and results. So we are interested in the figures and tables that you put in the report. And we would like to invite everyone to discuss the results and how can these be applied in large scale. I'll give you more information in the next slide. And for your video recording, we would like to invite everyone to create a video in order to show and walk the juries and judges through the procedure that you have gone through, what is important for you from a regional aspect, and what do you think about the concrete mix design that you propose as alternative case scenario. We would like to also invite everyone to participate in the video creation. So if all the team members participate in the video and presentation, there's going to be a plus for the competition. Make sure that you use your creativity when you are making the video to discuss the results and your calculation process, particularly how you optimize your concrete mixtures in order to consider the best results and the combination of the results for service life and environmental impacts. This is a very important part of your report and video that I would like everyone to pay special attention to, which is about the instructions and your insight on your alternative case scenario mixtures. Please read section 2.6 and 2.7 of the rules document on the ACI website, but I would like to bring this to your attention about the scale-up effort and the constructability of the proposed concrete mixtures. First of all, we would like everyone to talk about the potential in-use applications of the alternative case scenario that you proposed. Is this mix design applicable to pavements, buildings, precast elements, etc.? Just identifying and knowing your opinions about how to prioritize the implementation of these alternative case scenario in your region. Second, we would like to hear your thoughts on the constructability of this alternative case mixture, particularly the impacts on the project costs. For example, some of these SCM materials can significantly delay the setting time or early strain gain. So that will consequently affect the project timeline and might result in a delay in the project, which will incur some cost to the project, right? So we would like to hear your thoughts that how the new mix design affect the job site and the project schedule. Also, we would like to hear your opinions about the pumpability and the finishability of this proposed concrete mixture. Do you think that any adjustment needs to happen at the construction site when we move from the base case scenario to alternative case scenario? And we want to make sure that we have a comparative analysis here. It doesn't need to be like a fully quantified analysis, but at least having thoughts on those will give us more confidence about the scalability of the proposed concrete mixture in this competition. Here is an overview of the score calculation. So your final score is a combination of your performance for report writing, presentation, durability or service life estimation, and life cycle assessment. And you can see the weighting for each, like half of your score, final score comes from the quality of your report and your presentation, and the other half is from the results that you will obtain and the optimization that you will do to minimize the environmental impacts while improving the service life. What we need from you to submit is a PDF report, then a YouTube link of the recorded video. We have detailed instruction in the competition rule documents that you will see and you can follow to upload your video on YouTube and share the link with us. Then you would like to receive your filled out Excel tool, meaning that you would like to see your calculations for the life cycle assessments and see the final scores in the Excel tool. And lastly, we would like to have a version of your Life 365 results. The online tool allows us to generate a JSON format, JSON format, and then when extracting that final results, please include it in your submission package and send it to us. We invite at least the top 20 teams for the online interview and final ranking for this competition. Here, what I pretty much had to discuss with you, these are some of the documents that I would recommend everyone to study and learn more about the previous versions of the competition. There's an article in the Concrete International magazine. You can see the screenshot on the right. You can learn some of the lessons that we learned from the students in the previous versions of the competition as well. With that, I would like to thank you for joining this webinar. I'm going to pause here, and if there is any question, please feel free to share, and I'd be happy to respond as well.
You can type any other questions you guys have in the chat. If we don't have any questions in a couple of minutes, then we will be all set. Thank you again, Hassan.
Of course, it's a pleasure to be here. There's still time, I think. After this webinar, you can still send your questions to the ACI student activity, and we will discuss and we will provide a response, and we will post it on the FAQ webpage of the competition as well.
Absolutely. All right, on 11:30 at the dot. Let's see.
I see a question in the Q&A box,
Mhm.
and
Hello, can we consider using recycled aggregates in our ACS?
the implication of the recycled aggregates in the service life has remained a complicated topic because the Life 365 software cannot capture the true impact of the recycled aggregates on the durability performance. I would recommend not using recycled aggregates as a solution. But in general, we have seen the benefits that were reported for using recycled aggregates, particularly in those regions that have very limited landfilling space, and there's going to be a lot of benefits from an environmental perspective. So my short answer is please do not use recycled aggregates because we cannot capture their impact on the service life and durability.
Great question, Martin. Any other questions, feel free to ask in the Q&A box. Don't be shy. Mhm.
Again, there is a lot of information in the competition rule that I couldn't include all the details in the slide. Please feel free to read those pages and get back to us if there was any other question as well. But I just wanted to take this opportunity to give you an overview and some of the updates that we made on the rules and the calculations, and obviously the migration of the Life 365 tool to this online web-based tool. So you'd be able to have a better confidence when you go through the calculation and analysis procedure. I see there is a hand raised.
Let's
Is okay.
yeah,
It went
let's
down.
see. Oh, okay, yep. Oh, do we have a hand raised? Any other questions?
Not really, I can see, but please feel free to raise your hand and unmute and ask your question if you prefer as well.
Also, remember the webinar will be available online on YouTube afterward.
Very good point. Thank you for mentioning that, Jacob.
And we'll add a link to it on the competition page.
Jaden, please correct me if I'm wrong. The pre-registration or the advanced registration will be closed by March 10th, right? In 5 days.
I do believe so, yes.
Perfect. So make sure that your team is already registered before or by March 10th as well. Just a reminder.
Okay, let's see. I don't see any other questions. So with that, I think we are all set. Thank you again, Hassam.
Of course, it's a pleasure, and thank you very much, Jaden and Kenneth, for providing this opportunity for everyone in the industry and students to participate and learn more about the sustainability aspects of concrete.
Well, thank everyone for coming. If anyone else has any questions, feel free to email us. And the webinar will be posted shortly. Thank you all for coming.
Have a good rest of the day. Bye.
Have a good rest of the day.